Assalamualaikum and a very good morning everyone. My name is Imran Akhil and I will be explaining about the spot welding techniques, specifically the definition, advantages and disadvantages. So let's start with the definition of spot welding. Spot welding is a type of resistance welding. In simple words, it is a welding technique used to join two or more thin metal sheets together. And it is called spot welding because the joint is not made along the whole surface or along one whole line. Instead, the joint is made only at small selected points. These points are called weld spots. And as shown in the picture, the output of spot welding usually looks like a small circular mark on the metal surface. This mark shows the position where the metal sheets have been joined together. And spot welding is commonly used when the metal are overlapping. This means one metal sheet is placed on top of another metal sheet. The technique is very suitable for thin metal sheets because it can join them quickly without making a large weld area. And another important point is that spot welding usually does not require filler elements, filler metals. Filler metals means extra metals added during welding to fill in the joint. In spot welding, the original metal sheets are joined directly, so the result are simpler and cleaner. And a common example of spot welding is in car manufacturing. Car bodies are made from many thin metal panels, and these panels are joined together using many spot welds. So the main idea that spot welding joins thin overlapping metal sheets by forming small circular weld. So now that we understand what spot welding is, I will continue with the advantages and disadvantages of this technique. The first advantage of spot welding is that it is a fast process. Since the weld is only made at small points, it does not take a long time to form each weld. This makes it suitable for mass production, especially in factories. And second advantage is that no filler metal is normally needed, as mentioned before. This makes the process simpler because the machine does not need extra welding rods or additional materials to make the joint. And the third advantage is that spot welding is easy to automate. In industries such as automotive manufacturing, spot welding is often done by machines or robotic arms, and this helps produce many welds quickly and consistently. And another advantage is that weld is usually neat. The weld marks are small and circular, so that surface does not have a large weld bed like some other welding methods. And however, spot welding also have their own disadvantages. One disadvantage is that it is mostly suitable for thin sheet metals. It's not the best choice for very thick metals. And another disadvantage is that materials usually need to overlap. This means spot welding is not suitable for joint design, especially if metals need to be joined edge to edge. And spot welding also usually needs access from both sides of the material, meaning this can be a problem if the product shapes makes it difficult for the welding machine to reach both sides. And the equipment can also be expensive, especially in industries, machines or robotic systems. Because of this, it may be more suitable for factories rather than small workshops. And lastly, weak welds can happen if the machine settings are wrong. For example, if the current or pressure or time is not suitable, the weld spots may not be strong enough. And so in conclusion, spot welding is a useful technique for joining thin overlapping metals. It is fast, clean and good for mass production, but it also has its limitation in material thickness, joint design and equipment cost.
On this slide, I will explain the procedure of the welding step by step. So, firstly, it is positioning the metal sheet. Two thin metal sheets are placed in an overlapping arrangement between the two copper electrodes. Proper alignment is important to ensure the weld is formed at the correct position. Next, the copper electrode apply pressure to hold the sheet tightly together. This pressure improves the electrical contact between the metal surface and it prevents movement during the welding process. After that, a very high electric current with low voltage flow through the electrodes and across the contact point of the metal sheet. The current only flow for a short time. but it is strong enough to generate a large amount of heat. Next, the heat is produced because of the electrical resistance between the metal surface. The highest resistance occur at the interface of the sheet, so the heat become concentrated at that region. As the temperature increase, the metal surface begin to melt. Then, a molten weld nugget is formed at the contact point. This weld nugget acts as the joint area between the two metal surfaces. And finally, the current stop and the molten metal cold while the pressure is still applied by the electrode. After solidification, a strong permanent joint is produced. So, I can conclude the spot welding is a fast and efficient process that is widely used in industry such as automotive manufacturing and sheet metal fabrication. This slide shows the process sequence and actual illustration of the spot welding technique. First, the metal sheets are arranged in an overlapping position. The copper electrode then clamp the sheet tightly together. Besides applying the pressure, the electrodes also conduct electric current into the metal sheet. Next, a high electric current flows through the contact area between the sheets. Due to the electrical resistance at the interface, heat is generated rapidly. The heat becomes concentrated at the welding spot because that area has the highest resistance. As shown in the illustration, the generated heat melts the metal surface and forms a molten weld nugget. The size of the weld nugget is important because it determines the strength of the welded joint. After that, the required heat is achieved. The current stops and the welded being too cold. The electrode continue applying the pressure during the cooling to ensure the proper solidification and strong bonding. The image also show the industry application of the spot welding, especially in automotive factories where robotic systems are used for fast and accurate welding. Spot welding is preferred in mass position because it is quick, reliable, and easy to automate. In conclusion, the process sequence of the spot welding demonstrates how the pressure, the electrical current, and heat work together to produce a strong welded joint efficiently. Thank you.
Right, moving on to my first section, let's discuss the technique definition of submerged arc welding, which is commonly abbreviated as SAW. To define it simply, SAW is an automatic arc welding technique specifically engineered to create a deep penetration joints in the exceptionally thick metals. Because of this capability, it is a primary choice for the heavy-duty industrial fabrications where the structural integrity is critical, such as in shipbuilding, pressure vessels, and large cross-country structural pipelines. The absolute defining feature of this technique is the use of a thick layer of granular mineral flux that completely covers the welding zone ahead of the torch. Unlike the typical open arc methods like MIG or stick welding where you see a brilliant blinding light, the electric arc in SAW burns entirely hidden beneath this flux blanket. As the welding process takes place, this flux melts into a protective liquid slag crust, and this liquid layer completely seals the molten metal pool underneath, shielding it from the atmospheric oxygen and also the nitrogen contamination which eliminates the weld defects like porosity. Finally, because the high energy arc is completely buried, the process produces a zero visible arc flash and zero dangerous flying sparks and minimal fumes. And this makes it an exceptionally a safe environment for the operators, allowing high voltage automation to run smoothly without the standard safety hazards or traditional welding. That's all.
Now for the advantages and disadvantages of the submerged arc welding. Alright, firstly, for the advantages of the submerged arc welding, first, This method has a high deposition rate. This means it can deposit a large amount of weld metal in a short time, making it suitable for thick plates and heavy fabrications work. Second, it produces good weld quality. The granular flux protect the molten weld pool from air contaminations, which help reduce defect and produce a stronger weld. Third, this method gives deep penetrations. The heats from the electric arc allow the weld to fuse deeply into the base metal, making the joint stronger. Fourth, this method produces less splinter. Since the arc is fully covered by flux, the welding process is cleaner compared to open arc welding. And lastly, there is no visible arc flash because the arc is hidden under the flux. This reduces direct exposures to bright arc light and improve operator comfort. These advantages make submerged arc welding useful for high quality and high productive welding work. Next, for the disadvantages of the submerged arc welding, we will focus on 5 main points that were given. First, submerged arc welding has a limit welding positions. It is mainly possible for flat and horizontal welding because the flux powder and molten metal may flow away if used in vertical or overhead positions. Second, it is not suitable for thin metal sheets. This is because this method produces high heat which can burn through thin metal easily. Third, the arc cannot be seen clearly because it is hidden under the flux. This makes it harder for the operator to observe the weld pool directly during welding. Fourth, the equipment is less portable. This method uses larger equipment such as wire feeder, flux hopper, and power source. It is not easy to move around. And lastly, submerged arc welding has a high initial setup cost because it requires automatic feeding equipment and flux handling system. Because of these limitations, submerged arc welding is more suitable for large, thick, and continuous welding jobs. Alright, we will continue for the procedure of submerged arc welding. I will explain 5 important steps. The first step is preparing the joint. Before welding start, the metal plate must be positioned and aligned correctly. The joint can be a lap joint or a fillet joint, depending on the workpiece design. Proper joint preparation is very important because poor alignments can cause weak welding, uneven penetrations, or welding defect. The gap between the plates also need to be suitable so that the weld melter can fill the joint properly. The second step is applying granular flux. In submerged arc welding, flux powder is placed over the welding area. This flux covers the joint before or during the welding process. Its main purpose is to cover the arc and protect welding zone. Because of this flux layer, the arc is hidden and not directly visible to the operator. The third step is the melting process. When the welding machine starts, an electric arc is produced between the continuously fed electrode wire and the workpiece. The heat from the arc melts both the electrode wires and the base metal. This metal forms a molten weld pool which fill the joint and create the weld bed. The fourth step is flux protections. The flux protects the molten weld pool from oxygens and nitrogens in the surrounding air. This is important because air contaminations can cause defects such as porosity, crack, or weak weld. The flux also helps produce a smoother and cleaner weld surface. The final step is slug removal after the cooling. After the weld cools down, some metal flux become a hard slug layer on top of the weld bed. These slugs must be removed by chipping or brushing. Once the slug is removed, the weld can be inspected for quality and defective.
Now let's take a look at the integrated process schematic on screen, which illustrates both the physical welding and the mechanisms and the sequential engineering workflow of the submerged arc welding. If we look at the left diagram on the left, we can see how the hardware functions. A copper-coated bare wire electrode is continuously fed from the wire reel through a contact tube. Simultaneously, the flux hopper dispenses a granular flux bed directly over the joint line in the direction of the weld. The immense heat creates a hidden melt cavity forming a deep molten weld pool. Above it, the melted flux turns into a protective molten slag blanket which blocks out the atmosphere to prevent any oxidation or defects. To understand how this translates into an industrial process sequence, we can follow the flowchart blocks on the right. Step 1 is the joint preparation. The base metal plates are cleaned, aligned, and tightly clamped, and often used using a machine V-groove to allow for deep penetration. The second step is the flux deposition. The automated welding head moves into a position and the hopper deposits the granular flux bed right ahead the torch path. Step 3 is the arc strike and submersion. The wire is fed down until it contacts the metal under the flux layer, striking a high current electric arc that is completely buried and invisible to the naked eye. And step 4 is the automated fusion. This is where the electrical control loops take over. The servo control and drive motor constantly adjust the feeding speed of the wire to maintain a perfectly stable arc length as the metal fuse together. The last step is the finishing and slag removal. Once the weld cools, the molten slag solidifies into a brittle protective crust. A pneumatic chisel or hammer is used easily chip the slag away, revealing a clean, flawless, high-strength weld bed beneath it.